In this video tutorial, we will be showing you how to visualize data on a map, like earthquakes, rainfall, population, things like that, using JavaScript to help create an application that can be used in the browser or implemented onto a website. You will need a text editor. Like brackets, we will be using here. You can also use other text editors like Atom or Visual Studio. You're also going to need to know a bit of JavaScript and have a framework that you're familiar with. We will be using P5.js for this tutorial, and both the editor and the framework will be linked in the description. We're going to need a map or graph to place on our canvas. We will be using Mapbox for this tutorial. And also, we're going to need data, which we will be getting from the US Geological Survey website. So to start off, we're going to open our text editor. We're going to go up here to File, create a new file. We're going to rename this. I'm going to call it test work, and remember to save it as a .js file. Now we're going to save that, and now that we're in our editor, we're going to start making our functions. So to start off, we're going to need a setup function, and we're also going to need a preload function. Now I'm going to make this a little bigger so you guys can see what I'm doing. And in our preload function, we're going to be putting in our map and our data. So to get our map, what we're going to do is we're going to go to a place called Mapbox. And this website here, you're going to have to sign in or make an account. I'm going to go ahead and sign in here. And this is going to be able to give you a access token, which is this amount of text right here. You're going to need an access token when you're going to be using Mapbox. Now, that access token is going to be able to be used with Mapbox's static API, which labels itself here as longitude, latitude, the zoom, the width and the height in pixels of their API, which is going to be in the link right here. Now, when you get your access token, you're going to replace this text, this random text here, all the way until the equal sign right here, access token. Once you do that, we're going to close out of here, and we're going to make a variable for our map image. We're just going to call it map image, and we're going to say map image equals load image our map API, which I'm going to copy and paste from here and put the token at the end. After everything, it should look like this. And I'm going to extend this so you can see exactly what I'm doing. So here, a couple of changes we've made. Once we put our map API, I changed the styling. So I changed this to dark V9, which is going to give us a dark accent to our map, as you can see there. I changed the longitude and latitude to 0. I made our zoom 1, and I made our angle 0, so we can see it as a flat map. It comes standard, as you can see here, as a 600 by 600 resolution. I changed it to 1280 by 720 because I want a 720 resolution when I'm looking at it on the browser. Here, where after the equal sign, I put in my access token, and now we've set up our image. Now, what we're going to do is we're going to set up our variables for our longitude and our latitude. And we're also going to set up a zoom variable, which we're going to equal to 1. And these are all the same as our API here. Now, we're going to need a variable to hold our earthquake data. We're going to equal our earthquake data and say load strings. And we're going to be able to get our earthquake data from the US Geological Survey right here. Now here we can get data for all the most recent earthquakes from the past hour, the past day, the past week, or the past month. We can use significant earthquakes or all the earthquakes. Now, we don't want too much data, but we don't want too little data. We want something that can be represented on the map and be visually appealing, at least for this tutorial. So, each one of these is basically a Excel file, a .csv file. If we open this up, we're going to be able to see the data, earthquake data, from the last week. Now this might be a little overwhelming, but we're only going to be using 3 main parts of the data. We're going to be using the latitude, the longitude, and the magnitude of the earthquake. If you put it in an array, it's going to be numbered as 0, 1, 2, 3, 4. So we're going only to be using 1, 2, and 4 from our array in this data. We can close this out. We can actually just right click and copy the link location. Once we copy the link location, we can come back to our program and just print our data into the program. Once we have our preload function set up, we're going to start setting up our actual setup function here. So before we can actually see anything and run the program, we're going to need to create a canvas. And we're going to make it the same resolution as our API. So 1280 by 720. That's going to be the pixel length and pixel width. Now we're going to actually map our image onto the program, or onto our canvas. And we're going to say map image at 0, 0. Now, to see anything, we're actually going to have to reference this JavaScript file in our HTML file. So we're going to come here, and we're going to change this, when we're calling our script here for JavaScript, we're going to change this to the name of our file. So our file name is test work, and we're going to save that. Oh, we're going to undo that. Save that, keep changes. We're going to come here, and we're going to save this, and we're actually going to come up here, and we're going to run it in the browser and see what we see. Okay, so here in the browser, we're actually seeing our map. So perfect. We're going to exit out of that and continue working. So when representing data on a map, when we run this, we can see that the canvas of the map starts actually at top left at 0, 0. Now we're going to need to change that. We're going to move the 0, 0 coordinate to the middle of the map, because when you're looking at a Mercator projection, which this map is, the longitude and latitude starts at the center, not the top left. So we're going to need to enter some code here in our setup function to move that coordinate 0, 0 to the center. So we're going to type translate, and we're going to take our width divided by 2, and our height, and divide that by 2. And we're also going to change the image mode and put it in the center. Now we're going to have to translate each pixel into our actual longitude and latitude value on the map. So this is actually going to take some math, and what we're going to do is we're going to use the web Mercator projection. This will be linked also down in the description. And they have 2 formulas for translating longitude and latitude onto pixels on a flat canvas. So here's our x and y values. Now what we're going to do is we're going to copy these 2 formulas into our program. This symbol right here is just longitude, and this symbol right here is latitude. And we're going to split these 2 formulas into 2 pieces in our program. So if you move this to the side here, and move this here, we're going to make 2 functions for our x and our y value. Function, and we're going to call it Mercator x, and that's going to take a longitude value. And we're going to make a second function, Mercator y, and that's going to take a latitude value. And we're just using the exact same values, or the exact same variables, that we do up here. Now, we're going to copy over these 2 formulas into our program. And what we can tell here is that longitude is in radians, and so is latitude. So the first thing that we're going to want to do is turn longitude into radians. And then we're going to split up this formula into 2 parts. First part, 256, divided by pi. Then we're going to multiply that by 2 to the power of the zoom level. The second part of the equation, right here, is just longitude plus pi, multiplied by this whole thing. So we could say it's just longitude plus pi, and then return and we're just going to multiply it, a times b, and that's just going to be the first equation here, x represented as code in our program. Now, for the second program, it's a bit longer, so we're going to split it into 3 parts, and the first thing that we need to do is say latitude equals radians of the latitude. So what we're doing is we're just changing the values of latitude and longitude to radians to fit this equation. And then, since this is a longer equation, we're going to split it into 3 parts. So the first is the same as the first equation, so we can just copy and paste this here. And the reason that we're not multiplying pi by 2, like in the equation, is because some Arcadia projection of Mapbox, the API, doesn't have a pixel count of 256, it has a pixel count of 512, I believe. So we're not going to be multiplying pi by 2 here, we're just going to be leaving it as it is. Now, variable b, we're going to say, as the equation says, tan times pi divided by 4 plus latitude divided by 2. And then the last part of the equation, c, is going to equal pi minus the log of b. And then we're going to return that as a times c. And what that's going to do is, since we're incorporating b right here, this whole part, into c, we can just multiply a times c, and that'll give us the entire equation in radians for our x and y values, as shown here. Now all we have to do is to convert the data as points onto the map. So we're going to close this out, and move this here. And now that we have both our functions ready, we can actually come back to our setup function, and all we're going to need is a loop to loop around all the data and represent it as points on the map. We'll start here by creating a for loop. We'll equal I to 0, so it can start at the beginning of the spreadsheet. And we'll make I less than earthquakes.length, the length of the spreadsheet, so it goes through every single point of data. And we're going to add 1 to I every time we loop. So what we want to do is make a variable called data and equal it to earthquakes. Then we can make every point in that array do something called .split. So what this does is change the array from scrolling through the rows into scrolling through the columns, which is where our longitude and latitude and also magnitude is, which is what we're going to want to scroll through. Then we're going to make a variable for latitude and equal that to data at 1. And what this is calling is, remember when I was looking at the Excel sheet, our latitude is data 1. And our longitude is going to equal data at index 2. Our magnitude is going to equal data at index 4. And the reason we're using these numbers is because when we open up the spreadsheet here, we see that in the array, starting from 0, 0, 1, 2, 3, 4, we're using 1, and 2, and 4. So if we close this out, we can see that we're representing these variables as these indexes. Now, we're going to want to use the conversions that we use down here as our functions and change them in this loop. So we can actually come up here and just add 2 more variables. Call it central latitude, equal that to 0, and central longitude. And now we can come back to our loop and actually add these variables. So we get a central x equals merc x, and give it its parameter. And make another variable for central y, equal it to merc y, and give it its parameter. Just try to change this to an e here. Okay, now we can come back to our loop here and keep going. What we're going to need is a variable for x, and we're also going to need a variable for y. And we're going to equal x to mark x at long minus the central x. So what this is doing is taking the normal longitude value, putting it through the equation, and subtracting the difference between the top left corner and the center. So we're going to do the same thing for y, and we're going to give it its parameter, which is latitude, and we're going to subtract it from cy. Now we can start implementing magnitude into our program. Now, what we have to understand about earthquakes is that magnitude, a 5 magnitude earthquake and a 6 magnitude earthquake is 10 times a 5 magnitude earthquake. So what that means is that magnitude is logarithmic. It grows by the power of 10. So, when we're implementing magnitude, we can say mag equals 10 to the power of magnitude, and magnitude equals the square root of itself. Then, we can create a variable for magnitude max, equal it to square root 10 to the power of 10. So what we're doing is we're determining what the maximum magnitude is, and the maximum magnitude is 10 to the power of 10, which is the scale that earthquakes are measured at. And then we can make a variable here, equal to d, and now we can map our magnitude, 0, our max magnitude, 0, and then we can use an arbitrary number, just make up a number. I'm going to use 2,500, but you can go a little higher, you can go a little lower. This is just going to determine the size of our dots on the map, determining the magnitude of the earthquake. Now all we have to do is create the actual dots, which is pretty easy. We can say ellipse, create little circles for our dots, and give them their x and y coordinates, and make their diameter d times d, and this d is just going to be equal to the magnitude of the earthquake. Then we can also fill it, let's say with a color, and we'll just say that depending on the magnitude of the earthquake, the color might be a little darker or a little lighter. So we'll say d plus 100, and this fill is using RGB, so the values that you're seeing here are just the values of the red pixels, the blue pixels, and the green pixels. So we're just going to make them red and make them a little green so we can actually see. Actually, let's put some stroke in there. So stroke will give us some see-through, some clarity, so we can actually see the map and also the terrain under the circles, giving us sort of this see-through look. So we'll make it a little red, 0 and 0. So the stroke is also in RGB, so this is the value of red, and obviously each value is from 0 to 255. So a little bit of red, 0 green, and 0 blue. And we'll save that. And this is our entire program. I'll zoom out a little bit so you guys can see everything. Now, if we run our program, it'll open up in the browser, and we can actually see, there we go. So we have here a map of the Earth, different dots representing different earthquakes in the last 7 days, and the size of the dots representing the magnitude of each earthquake. Now, if we close this off, we can actually play around with this. If we want to change the theme, maybe we don't like that dark theme, we can change that dark to satellite view, and save that. And now, if we just run the program here, we see that now we're getting this sort of green view, and we're still getting the dots on there. You can always change the color. So let's say we want something more, let's say we want something green instead of red. We can set our red here and fill to 0. We can go to green, and we can say d plus 100. So the shade of green changes as the magnitude changes. We can save that, and we can rerun the program here. So here, now we're getting our dots in green. And you can also play around with it. A couple things to watch out for when you're building this program. If your spacing isn't right, you might get a lot of errors. You miss semicolons, things like that. Very simple mistakes. You might get errors. If you wrote the equation wrong, these are the little things you can check. And once you have it done, you can play around, you can add to it. You may be able to change little things here and there. Follow up and troubleshoot. Everything I used will be linked in the description. If you are having trouble with something specific, try changing some variables around and see what changes in respect to others. And most of this information can be found with some searching around online. So if you're having any trouble, you can probably find it online just by searching a little bit around. Most of these concepts are pretty fundamental, and hope you guys learned something. Bye.